everyone. This is Professor Jeff Wilkerson at Luther College, bringing you our What to Observe in the Night Sky for the week of November 23rd, next week. As you know, if you've been watching these, and I don't know why you wouldn't have been watching this video series, we look at things that maybe are good to look at next week for a week, but for a few weeks after that. Give you a chance to go out and observe something in the night sky. This one in particular, because this one makes no sense at all, because I'm going to tell you to look for something that the moon will be interfering with you next week. So don't, it'll make it particularly hard to see. But the following week, it'll be great. And the moon passing through here might actually help you find some of these things. So this is, this is what we're trying to do here today. And so the board's busy behind us, very busy. And we're going to tell the story of a hero of mine, someone that I don't think gets enough attention. And we're going to talk about Vesto Slipher. Often you'll see written as VM Slipher. VM Slipher. And the work that he did about 110 years ago, and helped us understand the expanding universe, helped us understand the nature of our galaxy and the nature of galaxies in general. And he's a native Hoosier like myself, was Vesto Slipher. And so you see this busy board with lots of stuff going on, and we'll walk through where to find. Our goal here is to walk through where to find galaxies M74 and M77, and particularly M77 right here is one that we're really interested in. And we're going to talk about this and Slipher's measurements of M77 in the 19 teens and what we were doing. So if you've watched these videos, again, you know that the last couple of weeks we've talked about the Milky Way Galaxy. And a galaxy is a self-gravitating group of stars that is isolated from other such groups of stars, very large, hundreds of billions of stars often. And so the Milky Way is a spiral galaxy, meaning that it has a central bulge and spiral arms that come out of there, and we live in one of those spiral arms. But if you go back 100 years, we were really struggling to try to figure out both the nature of what our Milky Way Galaxy was and what these smudges of light in the sky were that we called spiral nebulae. And some people were arguing that these were galaxies like the Milky Way, and some people were arguing that these were just little wisps of gas within our own Milky Way. So you could sort of think of this as a big universe, small galaxy model, where these are other galaxies like the Milky Way, or a big galaxy, small universe model, where the Milky Way Galaxy, the conglomerations of stars you see in the night sky. When you go out walking in the night sky, you go out and look at the night sky, every star you see, you're like, oh, there's a nice star, there's a nice star. Every one of those stars is in our Milky Way Galaxy. And so you're seeing these foreground stars. Think of it like being in a forest. You see the foreground trees, and then eventually they just merge into background forest. And that's the hazy band that you see on the sky. That's the disk of our Milky Way Galaxy. The spiral arms of our Milky Way Galaxy is that hazy band that we often call the Milky Way. And that's the background forest where the trees have just merged into forest. And so that's what you're seeing when you go out there and you look. But there are all these little smudges of light. And so to try to understand what these were, one of the things that Slipher did was to try to take spectra of these spiral nebulae. And a spectrum looks something like this. So you see these different spectra right there. You have different types of spectra, and you see the different colors of light. So basically, if you've seen light, you've seen the rainbow, or light shining through a prism, you break the light up into the component colors. And he was trying to break the light up into the component colors of these spiral nebulae, but this was really hard because these things are really faint to begin with, and then you take the light and spread it out, and the photographic plates of the time weren't exactly the most sensitive things by today's standards. And so this was really challenging. So challenging that he couldn't get the spectrum of one of these spiral nebulae just by looking at it all night. He had to cap the telescope, get everything realigned, and open it up the next night and the next night and the next night, and just keep letting light flood in there, more and more and more light. This is a challenge. This is a technical challenge. It's just really, really absurd to think about how hard this job was. So it was really genuinely heroic effort on Slifer's part to measure the spectra of these spiral nebulae. And what he found was that the spiral nebulae had spectra that looked like the bottom spectrum in this diagram right here. And so looked like what we call an absorption line spectrum that would be typical of stars. So that suggested that maybe these little fuzzy patches, which just looked like a little haze of light, were actually made of stars, which would suggest that they were very, very distant. But what he also found out is that these lines were shifted from the place you would expect them to be. They weren't the same wavelength. They were shifted right or left in this diagram right here. And so that is a Doppler shift. And if something's moving toward us, it's shifted toward the blue end of the spectrum. And if something's moving away from us, it's shifted toward the red end of the spectrum. And we can tell how fast it's moving. And what he found is that almost all of these were moving away from us. A few of the biggest and brightest were moving toward us. But most of these spiral nebulae were moving away from us. And some of them were moving away from us at staggering speeds. The Earth orbits the sun with a speed of 30 kilometers per second. So we're moving 30 kilometers per second through space as we orbit the sun. He found some of these galaxies to be moving over 1,000 kilometers per second, 30 times faster than the sun's orbit, away from us. And so these things were really zipping away from us. And what happens is if you plot how fast these things are moving away from us as a function of distance, you get a linear relationship, the Hubble-Lemaitre law, that says that if you double the distance a galaxy is away from us, twice the speed of recession that it has from us, which leads us to think, this space itself is expanding and pushing these galaxies apart. Twice as much space expanding, twice as much recession velocity. So we don't think about those galaxies moving through space. We think about space expanding and pushing those galaxies away from us. And so this is all built up in the work that Slifer's doing here, taking the very first spectra. Now, if you read, if you read, say, this is an outstanding reference book, Robert Burnham's Jr.'s Celestial Handbook here. And if you look at that, there's a spiral galaxy right on the front. That looks like M51 to me, the Whirlpool Galaxy. And so you got a spiral galaxy right there on the front. But if you read this book, he'll tell you that M77 right here was one of the first two of the spiral nebulae that Slifer measured a recession speed for that was enormous. And that recession speed is one of the ones that's over 1,100 kilometers per second. This galaxy is moving away from us. He said this was one of the first two that he measured. I don't know that. I trust Burnham. What I do know is that in a paper published in 1917, Slifer listed the recession speeds, the speeds away from the solar system of 25 spiral nebulae, and M77 was one of them, and it was one of 4 in that list of 25 that had a recession speed of over 1,000 kilometers per second. So certainly I have a record there that I've read this paper where Slifer has published one of the first 4 that's moving away from us at enormous speed. So let's go try to find it. That's what we're going to do. So that's a whole setup, a long introduction to setup to say, can we find this galaxy? You might be able to see it in binoculars. If you have good, large aperture, 50 millimeter binoculars, my guess is you could see this. But for sure you could see it in a small telescope. And we'll see some other interesting things along the way. As you've watched the last several weeks, the Great Square Pegasus has been the star of the show often for us. It's well placed for observing in the evening right now. Go out at 6:30, 7:30, 8:30 at night and look south, and there it is. You got the Great Square Pegasus hanging high over the southern horizon if you live in mid-northern latitudes here, like I do in Decorah. Just below the Great Square Pegasus is Pisces. And Pisces is a string of really faint stars, hard to see. You got this, what's called the circlet. This group of little stars comes back and forms a sort of Y shape up this direction. Okay, Mars is very bright there. We looked at this just last week. Mars is very bright. If you take the great square of Pegasus, boom, boom, and you'll find the brightest object in the sky, this region of the sky right now, is Mars, and until the moon gets there next week, this week. And so Mars is right there, and so that helps you find Pisces. So Pisces is this constellation. Now below Pisces is another string of very faint stars, Cetus. And Cetus, we'll probably come back to. There's another object in Cetus we want to talk about relative to the research work that I do. And so we'll probably return to that in the next few weeks while Cetus is well placed to observe. And we've talked about the bright star Diphtha here. And I don't know whether we've talked about Menkar or not in Cetus in recent weeks. But Cetus is a faint constellation as well. A lot of faint stars scattered throughout here, but these two stars are brighter than anything you find in Pisces and rival the stars of the great square Pegasus up here. So you can look to find Menkar and Diphtha. Now, what's going to help you too is the moon, and it's going to hurt you. The moon will be filling out. It's a waxing gibbous moon. It's starting to fill out during the week of November 23rd as you pass along there. We'll have a full moon on the 30th. And so as it's filling out, it's moving this direction. So on the 25th, Wednesday, the night before Thanksgiving here in the United States, it'll be very close to Mars. Go out and look at it. Beautiful, beautiful sight to have the moon this close to Mars on the night of the 25th. By the time you get to Friday night, the day after Thanksgiving for us here, it will have moved up here and will form a sort of triangle with M74 spiral galaxy and M77 spiral galaxy and be relatively close to the brightish star Menkar. So if you want to find Menkar, go out on Friday night and the moon will get you there. Now, let the moon pass on through the area and get out so it's not flooding it with light. And so the next week you can go out and you can look for M77. And when you do, you start at Menkar and move down to this other star that's not nearly as bright as Menkar, but is still bright enough to be visible. It's still a reasonably bright star in Cetus there. Kefalstamar is right here, okay? So you find this star, you move down diagonally like this, about the same distance, and you come to a star that doesn't really usually have a common name, and we call it's Delta Seti. So Delta Seti would be this star. Now Delta Seti is a fourth magnitude star. Sure, you can see it. It's pretty low on the horizon. You got to have a pretty good dark sky to be able to see it well. A pair of binoculars will pop it right out. So you go boom, boom, and find Delta Seti. Now when you do that, within a degree, within a finger's width or so of Delta Seti, off here to the southeast is M77, the spiral galaxy. And so use your binoculars. If you use your binoculars to find Delta Seti this way, use it to see if you can find M77. If you have a small telescope, just scan a little bit down and left, as drawn here on the board, from Delta Seti, and you can find M77, and you'll see it as a faint smudge of light. It's a nice galaxy to observe, and it's a good one to see. I observe it whenever we have a chance to with the equipment that we have here. It's a fun one to see, but I like it a lot because I know that Vesto Slipher, this was one of the galaxies that he first measured, this ridiculous 1,100 kilometer per second. Remember, we orbit at 30 kilometers per second, 1,100 kilometers per second of recession velocity. And this is on the way to our understanding of the expanding universe. This is really the first step to our understanding that the universe itself is expanding. And while you're here, you might as well go try to find M74 up this direction. And so as you follow the stars of Pisces here, you can look for this star in Pisces on Wednesday the 25th. It'll be the moon will be directly between it and Mars. And once you've located that star and you have that star locked in your memory of where it is, you move up the chain a couple of stars, and right there is M74 next to this star. So you can think about moving across moving across something along from the great square of Pegasus and see if you can find M74. So I leave that to you as a challenge, is to say our real target here is M77, but because of the history that it has in helping us understand the expanding universe and what's going on there. But while you're looking at galaxies in this part of the sky, why don't you try to find another spiral galaxy there, M74, and identify these stars as you move through there. So you start to learn the stars of Cetus. a little bit better than maybe you've known them in the past. Watch the moon slide past here, particularly on the night of Wednesday the 25th, where the moon will make a really beautiful pairing with Mars. And have a great week of observing, everybody. Hope you have clear skies.